if I want a solution curve to pass through the point x0, y0 in the xy plane. So what I do, purely algebraically, is I replace x by x0, y by y0, and solve the resulting equation for c, namely y0 equals x0 c minus c squared. And I now observe, remember, x and y look like variables. With the subscript 0, they represent fixed x and y coordinates of a point. C is the only variable in here. In other words, this is a quadratic equation in C. And solving this quadratic equation by the quadratic formula, I find that C is equal to this expression here. Remembering that we're dealing with real variables, I now know that I'm in trouble if this thing here happens to be negative. In other words, if this is negative, I have an imaginary number when I take the square root. In other words, there will be no solution, at least of this particular type. There'll be no solution to this equation if y happens to be, if y0 is greater than 1/4 x0 squared. And that means there will be no solution if you're above the parabola y equals 1/4 x squared. Remember, the set of all points x comma y for which y is greater than 1/4 x squared means you're above the parabola y equals 1/4 x squared, because on that parabola, since y is equal to 1/4 x squared, you would have to go above that to make y greater than 1/4 x squared. By the way, you see, all this proves is that there is no solution of this type to this particular equation if you're above the parabola y equals 1/4 x squared. The question is, what if I didn't give you this as a hint? Suppose I just gave you this equation, didn't even give you a hint as to what the solution should be, and just said, tell me where there will be solutions. Notice that you did not need this piece of information to get started on this problem. Namely, all you had to say was, gee,